Graphing two variable inequalities. So, if you remember these two things, then you will be all set to graph two variable inequalities. One is we have to know how to solve a system by graphing, which is to graph the two equations on the same graph. So the first one has a y-intercept of -3 and a slope of 4. So this is our line. And then the second equation has a y-intercept of 11 and a slope of -2/3 going down to right 3, down to right 3, down to right 3. Gives us a y-intercept of, gives us this red line. And we see that where they intersect is our solution. Our solution is, I believe in this case, 3, 9 is the solution. The other skill that we need in order to do this is to know how to graph this inequality. Well, you solve the inequality. So -2x is less than 10, and divide by -2 on both sides to get x is greater than -5. So we put an open circle at -5, and because this is greater than, we will shade to the right. If you've forgotten these, go back to solving the system by graphing, solving systems by graphing, as well as graphing one variable inequalities, because you'll need those skills in this lesson. So x equals 5 is graphed like this. It's a single point. X is greater than 5 is saying, oh, it's the numbers on one side of that point. Well, just like a line, y equals 2x minus 1 is a line, when you start comparing things, what it's doing is it's splitting the coordinate plane into two pieces. It's splitting it to the numbers greater than, the ones equal to, and the ones less than. So these are the ones where y is greater than 2x minus 1. These are the numbers where y equals 2x minus 1, and these are the numbers where y is less than 2x minus 1. So what we'll do is we will be shading parts of the coordinate plane. Each line divides the coordinate plane into two half planes. So y is less than or equal to, you see a solid line here, because those points make it true. And those points also make it true for y equals, and also for y is not equal to. But once you start seeing the less than or equal to, the not equal to, or the greater than, these three symbols all have dotted lines because those points on the line do not make the inequality true. You should know which way to shade for each of these symbols. What's important is not the left and the right, but rather above and below. This rule also only works if y is by itself on the left side of the equation or inequality. So we will use the inequality sign to determine whether it's solid or dotted, graph the boundary, which for our purposes will be a line, and shade the side of the line that makes the inequality true. So 2x plus 3y is greater than or equal to 33. The first thing is to say that that is solid. That's a solid line. Now, we will graph this line, which involves getting y by itself. So divide by 3. Y is greater than or equal to -2/3 x plus 11. So we go up to 11. We're going down to right 3, down to right 3. I'm using closed dots because it is a solid line. And that's our boundary. So now we've done steps 1 and 2. Now we check whether we're going to be shading above or below the line. Because its y is greater than or equal to, we will shade above. If you're not sure, you can always test a point on one side of the line to see whether it works. Say, let's plug in 0, 0. Let's see if that point is a solution. Well, is 0 greater than or equal to 0 plus 11? Is 0 greater than or equal to 11? No. This one is false. So this point is not true. The other points on the other side of the line are. All right, this is going to be a dotted line, open circles. Now we solve this for y. Subtract 6x. Negative 3y is greater than negative 6x plus 15. Divide by negative 3. Ooh, remember, when we divide by a negative, we flip the inequality sign. So this becomes less than 2x minus 5. And now we have negative 5, slope of 2. Again, if you're forgetting how to graph lines, that's a key skill that you need to remember. Now, which way are we shading? Because it's dotted, because it's less than, it's dotted, and also because it's less than, we will be shading the numbers with smaller y-coordinates. So the smaller y-coordinates in this case are on the right side, but more importantly, below the line we graphed. Here, y is less than or equal to negative 2x plus 5. So this is a solid line. It's a solid line. It's already in y equals mx plus b form, so we don't need to solve it. We go down to right 1, down to right 1, down to right 1. Take our line. And now, because it's y is less than or equal to, we shade below that line. Here, this is in point slope form, so if you remember your point slope form, you know that this line goes through 1, 2 and has a slope of 4/5. So I'm going to just do that rather than solving for y first. But we should remember that this is a dotted. This is going to be a dotted line because it's greater than, not greater than or equal to. So 1, 2, and then we're going to go up 4, right 5, and then up, there's no more, down 4, left 5, down 4, left 5, and that's going to be our line. That's our boundary. Now, the numbers that are greater than, well, if we add 2 to both sides, it'll still be y is greater than. So we can say it's the points above the line. X is greater than 5. Well, that says it's a dotted line. If you remember how to graph x equals 5, that's a vertical line starting from x is 5. So we go to x is 5, make our vertical line, and now we say x is greater than 5. These are the points with an x-coordinate larger than 5. Y is less than or equal to negative 2. Well, the y-coordinate is being compared to negative 2. This is the line, and it's going to be a solid line because of the greater than or equal to. And then y is less than or equal to tells me I'm shading below. Thank you.